So we just looked at the function 2 raised to the x. That was the exponential function that we were able to categorize a bunch of things about. Now what I'd like to do is generalize this. So what if it's not just 2 to the x? What if that base is allowed to be anything that we said it could be? So what if it happens to be 3 to the x? Or what if it's 1/4 to the x? What changes with some of those? So the major characteristics that we'd like to study with these exponential functions are going to be the domain, range, horizontal asymptote, vertical asymptote, x-intercept, and y-intercept. So if you look back at that previous video, you can see what all of these answers were for 2 to the x. Then, if we now try to think about it, what if it's just a general b to the x? So even if you compared and contrasted 2 to the x and 1/2 to the x, we saw those two graphs, both of those, you should see the domain is negative infinity to infinity. The range of this, both of them were above the x-axis. So the range of both of these was 0 to infinity. The horizontal asymptote was the same for both 2 to the x and 1/2 to the x, and that was both y equals 0. The vertical asymptote we saw in both of the cases, there is none. The x-intercept in both cases, it doesn't cross the x-axis, so here there is none. The y-intercept, now this one maybe gets a little bit trickier. So if we think about, say, y equal b to the x, and then if I set x equal to 0, I get y is equal to b to the 0. Well, we said 0, anything raised to the 0 power is going to be equal to 1. So my x-intercept is still 0, 1. Or sorry, my y-intercept is still 0, 1. So in general, every type of exponential function that's just b to the x has these same characteristics, whether or not that base is going to be greater than between 0 and 1 or larger than 1. Now, some of the other attributes that we saw, like for instance, the increasing versus decreasing, we saw 2 to the x, that was always going up. But 1/2 to the x, that was always going down. So the intervals of increasing and decreasing, that would definitely be different. So one thing that we have to be careful of is that we're not only going to be studying b to the x, right? That's going to get very boring. We're going to be applying various graph transformations. So remember, graph transformations, those would be things like if I multiply this by a number out in front, and maybe it's a constant, maybe it's something negative, maybe I multiply the x by a number, maybe I add or subtract numbers to this. Maybe I add and subtract numbers to x. So there's lots of different variations that we will be studying in this class. So for an example, if I look at, say, a times b to the x, this is going to be one of the important types of graph transformations that we can base it off of b to the x, but when we multiply by a number in front, remember that corresponds to the graph transformation of vertical stretching or vertical compressing. So if this number in front, if this was something larger than 1, or the absolute value of it was larger than 1, then it would be vertical stretching. If that's between 0 and 1, then it would be vertical compressing. And then if this number is negative, though, so if there's a negative, that also corresponds to the graph transformation of a reflection over the x-axis. So if we were to graph -3 times 2 to the x, this negative is corresponding to a reflection over the x-axis. And this 3 corresponds to a vertical stretch by 3. So we're going to study graph transformations a lot in the next section, but I just want to have you see that some of our properties are going to be different based off of these graph transformations. So if we were to take a look at, say, just a general a times b to the x. So if we say use this as a nice example to see how things are different, well, the domain, it's still the same, right? If you're vertical stretching a graph, that's not going to change the x values you can plug in. And if you're reflecting it over the x-axis, that's also not going to change the x values you can plug in. So our domain is still -infinity to infinity. Our range in this case is very different, right? Our range for just b to the x, we always thought that was going to be above the x-axis. Now this one, if this was just a +3, then it would just vertical stretch by 3 and it would still stay above the x-axis. So what's going to change is whether or not we're reflecting it over the x-axis, and that's going to be determined if this a is positive or negative. So our range is going to be 0 to infinity if a is larger than 0, or it's going to be negative infinity to 0 if a is less than 0. So if a is positive, it stays the same as it was before. If a is negative, it flips it over the x-axis, and now the range, the y values are all negative numbers. The horizontal asymptote, notice when all we're doing is vertical stretching and reflection over the x-axis, the horizontal asymptote is going to remain y equals 0. Now, this will change based off of other graph transformations. So if we think about if we're doing some type of vertical shifting, if I'm shifting this up and down, that's obviously going to change where this line is or where this curve is going to be approaching. So the horizontal asymptote is y equals 0 for just a times b to the x, but other transformations will change that. The vertical asymptote, this will also remain as none. The x-intercept, this also will remain as none. But again, if we talk about the graph transformations of vertical shifting, that very well could change. My y-intercept, though, this is definitely going to be different, because if I plug in x equals 0 into this, so if I set in y is equal to a times b to the 0, remember b to the 0 is just 1, so I have 1 times a, that's just a. So my y-intercept is going to be 0a. So this number over here that's vertical stretching this, that will indeed shift, or will stretch where this x-intercept or where this y-intercept will be. So that's what it looks like in general, and we will continue to add more graph transformations in 6.2, but for right now, hopefully that just gives you some understanding that this is true for any basic one, but graph transformations will be changing these.